The Pythagorean theorem is one of the most well-known theorems in math. It states that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. More commonly, it's just referred to as a squared plus b squared equals c squared, where a and b are the legs of the right triangle, and c is the hypotenuse of the right triangle. You can use the Pythagorean theorem to find a missing side length for a right triangle. If you know the two legs are 4 and 5, then 4 squared plus 5 squared has to equal the hypotenuse squared, since it's a right triangle. So 16 plus 25, which is 41. So x is the square root of 41. In example B here, they give you the hypotenuse in one of the legs, so x is another leg. X squared plus 8 squared equals 12 squared. So x squared plus 64 equals 144. Subtract 64 from both sides. You get x squared equals 80. So x equals the square root of 80, which can actually be simplified. That's 8 times 10, 4 times 2, 2 times 5, and 4 is 2 times 2, so we have simplifying this, we get 2 times 2 is 4, x equals 4 square root of 5. And example C, they give us all three sides in terms of x, but we can still use Pythagorean theorem. X squared plus x plus 1 squared equals x plus 2 squared. So this will involve some foiling, multiplying out these binomials. When we do that, we get x squared plus 2x plus 1, and the original x squared we had there. Multiply out x plus 2 squared, we get x squared plus 4x plus 4. And since it's a quadratic, we want to move everything to the same side of the equal sign. So when we subtract x squared, it will cancel one of those. When we subtract 4x, and we will subtract 4, we have x squared minus 2x minus 3. This can be factored because negative 3 is negative 3 times 1, and negative 3 plus 1 equals negative 2. So you can factor it to be x minus 3, x plus 1. And when we solve that, we get x equals 3 and x equals negative 1. But side lengths cannot be negative, so x equals 3. So this side would be 3. This one would be 3 plus 1, which is 4. And then the hypotenuse would be 3 plus 2, which is 5. We can also use Pythagorean theorem to find the area of a square if we know the diagonal is 10 inches. We're also told that it's a square, so we can use that as we're solving. So if the diagonal is 10, it is a square, so the two legs would be the same length, and the diagonal would be the hypotenuse. So we get x squared plus x squared equals 10 squared. 2x squared equals 100. So x squared equals 50. That's 25 times 2, 5 and 5. So x equals 5 square root of 2. A slightly different way to apply Pythagorean theorem would be to check and see if a triangle is a right triangle, to see if Pythagorean theorem is true. So for that, you need to plug in to the Pythagorean theorem. And in order to do that, you need to know that the hypotenuse is always the longest side, so C has to be the biggest number, the longest side. So for example A, 11 squared plus 15 squared, and you're checking to see, does that equal 19 squared? 11 squared is 121. 15 squared is 225. And 19 squared is 381. When we add 121 and 225, that's only 346. That does not equal 381, so it's not a right triangle. We'll apply the same process for example B. 7 squared plus 16.8 squared. Does that equal 18.2 squared? I misspoke over here. It's not 381, it's 361. But it's still not equal, so it's still not a right triangle. So back to this example, 7 squared is 49. 16.8 squared is 282.24. And 18.2 squared is 331.24. $282.24 plus 49 is 331.24. So those are equal. So yes, it is a right triangle. So there are some special cases, special instances where the Pythagorean theorem is a little bit easy to remember and related to the angles. And the first special case is a 30, 60, 90 triangle. So it has to be a right triangle where the other two angles are 30 degrees and 60 degrees. And if that's the case, then we have the hypotenuse. The short side is half of the hypotenuse, and then the long leg is the short leg times the square root of 3. So you could summarize that as it is in this drawing here. S over 2, and S times the square root of 3 over 2. I actually remember this as 1, 2 square root of 3. And I normally think of it as the hypotenuse as being double the short side. So the short side is the 1x. The hypotenuse is double that side, and the long leg is the square root of 3 times the short side. They are equivalent, it's just different ways of representing. So if you know it's a 30, 60, 90 triangle, you only need one side length, and then you can find the others. So for this first example, we have the hypotenuse, which is 4. The short side is half the hypotenuse, so it will be 2. The long leg is the square root of 3 times the short leg, 2 square root of 3. In example B, we're given the long leg, and we need to find the short leg and the hypotenuse. Well, the long leg is usually that one that has a square root of 3 with it, but this given triangle does not have a square root of 3 there, which means in order to get the short leg, we actually need to divide by square root of 3, because that's the only difference. The long leg is the square root of 3 times the short leg. So divide by square root of 3 to get the short leg. And when you do that, you're supposed to rationalize the denominator, which means multiply by that square root on top and bottom. So on the bottom that becomes the whole number 3, and top is 5 square root of 3. That doesn't simplify any further than that, because 5 over 3 does not reduce. And then our hypotenuse is always double the short side, so instead of 5 square root of 3 over 3, it will be double, so 10 square root of 3 over 3. The other special right triangle that we're going to look at is called a 45-45-90 triangle, or a 45-45 degree right triangle. And for that, since the angles are the same, it will be an isosceles triangle. So the two legs are the same, and then the hypotenuse is just square root of 2 times the legs. We are going to use 45-45-90 triangles to help us find the area of the parallelogram. If we draw the height of the parallelogram here, it will make a right triangle. Since this angle is 45, so is the one up top. So since the length is 3 feet 6 inches, that would be easier to write as in just inches rather than mixed units. So 3 feet would be 36 inches, plus 6 more inches is 42 inches. That's what this other diagram is showing. 7 feet 2 inches converted to just inches would be 7 times 12, which is 84, plus 2 more makes 86 inches. And we do have the height drawn in. In order to find since it is a 45-45-90 triangle, in order to find the height, we just need to use our fact that we know the hypotenuse is the square root of 2 times the leg. So if we divide by square root of 2, we'll get the height. And we already know how long the base is, and then to find the area, it's just base times height. Since the directions say to the nearest square inch, we will just approximate this using a calculator. 42 divided by the square root of 2 is 29.7 inches times the base, which is 86, comes out to be 2,554.2, so near square inch would just be 2,554 square inches.